Here we want to learn few practice problems for derivatives using different formulas. Let's do one at a time. Part A. Y is square root of x4 plus 6. You see there is an outside function and there is an inside function. So this is usually a chain rule problem. If y is f of g of x, f is an outside function and g is an inside function. The derivative of y is outside function's derivative keeping inside as is times the inside function's derivative. Okay, that's how you remember. So we need to find the derivative. Outside function here is the square root. The derivative of outside function is 1 by 2 square root. But whatever is inside, I'm not going to even touch, is x plus 4 plus 6 times the derivative of inside. Don't touch the thing which we already done. Times the derivative of x4 is 4x cubed. 6's derivative is 0. We can cancel this. 2 times 2 is 4. So the answer is 2x cubed divided by x4 plus 6. Let's work on part B. Y is x4 minus 3x cubed minus 8x plus 3 pi. The formula which is being used here is simple power rule. If y is equal to xn, dy by dx is power comes down, power 1 less. Also, if y is a constant, then the dy by dx is just 0. Okay, let's find the derivative. For the first one, 4 comes down, power 1 less, minus 3 times the power comes down, power 1 less, minus 8 times power is 1. So remember, if y is equal to x, then the derivative of y is just 1. So that is just 1. And 3 pi is just a constant. The derivative of that is 0. So what do we have? 4x cubed minus 9x squared minus 8 is your derivative of this function. Let's do part C. Y is equal to x by 2x plus 1. This is a quotient of two polynomials. So if we have y is equal to f by g, then derivative is denominator square, numerator's derivatives times denominator minus numerator as is times the derivative of denominator. So let's work on this. Denominator's square, numerator's derivative times denominator as is minus numerator as is times the derivative of denominator. The derivative of x is just 1 times 2x plus 1 minus x times derivative of 2x plus 1 is 2 divided by 2x plus 1 whole square. 2x plus 1 minus 2x divided by 2x plus 1 whole square. This will cancel. We will have 1 answer as 1 over 2x plus 1 whole square. Let's work on part D. F of x is x sine x. Here we have product of two functions. If y is equal to product of two functions, the derivative is first function's derivative times second function as is plus first function as is the derivative of second function. So let's work on that. We need to find the derivative of f. Derivative of the first function times sine x plus first function as derivative of sine x. Derivative of x is 1 sine x plus x times derivative of sine x is cosine x. The answer is sine x plus x cosine x. The function is 3x plus x squared sine x. We need to find the derivative. The first is very easy. It is just derivative of 3x, power is x is 1, so that is just going to be 3, plus this one here is product of two functions. You guys remember, if y was product of two functions, then derivative is first function's derivative, second as is, plus first function derivative of second. So the derivative of x squared times sine x as is plus x squared as is derivative of sine x. You guys should remember that derivative of sine x, the formula was cosine x. So answer is 3 plus 2x sine x, because derivative of x squared is 2x, plus x squared, derivative of sine x is cosine x. This is your answer to the questions. Let's work on part F. Here the function is of theta, tangent square n theta. This can be written as tangent n theta power 2. So the most outside function here is power. Then we do the derivative. We first differentiate the most outside function. So power's derivative is power comes down. Power of tangent theta as 1. Times we need to differentiate the inside too. And we are differentiating with respect to the variable. So 2 tangent n theta is here. The derivative of tangent is secant square n theta, that is the outside function, times there is an inside function, you notice. So we need to differentiate that. 2 tangent n theta times secant square n theta times the derivative of n theta with respect to theta would be just n. We are good with this answer, but you can write n in the front. That looks just nicer. This is your answer to the problem.